Hello friends, welcome back to Great Ethics program. We are presenting Insight Fellowship program in Advanced Analytical Problem Solving Expertise Ethics program. As we all know, we are in the middle of Six Sigma Green Belt, specifically into analyze phase. I am Santosh Naneshwar Avsarkar. So let's go to next slide and try and understand where we're standing. Next slide, please. Right, so we started with define phase, we completed define phase, then measure phase, right? So in define phase, we tried and find out the least of different probable problems, then we prioritize problem to work upon in a upcoming or immediate quarter. Once we prioritize the problem, then we quantify the problem and set the improvement goals and we document it. And post that, we try to see or we try to locate where that particular problem lies into the process with the help of high-level process map. That's the define phase. Then in measure phase, of course, we somehow converted given problem into measurable characteristics like target, specification limits, and defectives. Then, as we all know, y is equal to fx. If we do have prioritized problem, every single problem must be having certain causes behind it, which influence the problem. So we need to find out probable causes, the list of probable causes, and that's what we did. Then, we somehow converted that list of probable causes into the list of selected critical causes with the help of CI matrix. Then from once we got those critical X's, from the CI matrix, we need to statistically test those X's, those critical X's, and that needed certain sort of data collections, and that's where we collected the measure phase data. Once measure phase data is just a moment. Once the measure phase data is collected, all we left is to find out how critical the problem is. So based on capability assessment, we somehow find out the capability of as is state, that is a measure phase. So in measure phase, whatever y we collected, we try to find out where process is standing in measure phase, how efficiently or effectively given process is meeting client specification. That's what we did in a measure phase. So after define and measure phase, we enter into analyze phase. And in last video, we try to understand the conceptual, briefing, or we had a conceptual briefing about hypothesis testing, like how we're supposed to state the hypothesis, null hypothesis, and alternate hypothesis, steps of the hypothesis testing, importance of the hypothesis testing, then p-values, and how we're going to infer based out of p-values, how much is the risk associated, and then all those stuff we have seen in analyze phase. And now we are entering into second part of the analyze phase, where we are going to actually do some statistical testing based on breadth programs or breadth programs on the statistical tool. So on that particular note, let's go to next few slides and understand what's there for us in those next few slides. Let's go to next slide, please. So analyze phase, step number 3.2, statistical inferential analysis. And here for statistical inferential analysis, we're going to use chi-square test. So do remember, we're going to use chi-square test over here. So let's go to next slide, please. Next slide, chi-square test. So for statistical analysis in our Six Sigma projects, please do remember we're going to use chi-square test. Next slide. Right. So we have a list of prioritized critical causes from CI matrix. Now we want to go to second level to further prioritize those critical causes into statistically significant causes. That's what we want to do in second level. So can we say one or few of segregated prioritized causes from CI matrix have statistically significant impact upon Y? To find it out, we will use statistical test called chi-square test. Let's go to next slide and understand about chi-square test. How are we going to use chi-square test in much detail? So our focus is to learn how to use chi-square test and not how to get into conceptual understanding of chi-square test. You can definitely understand it as and when we keep on getting into solving problems based on statistical significance, of solving problems based on Six Sigma based statistical analysis. We are going to know about it in detail, but right now our focus is to know how to deploy chi-square test with the help of team breadth statistical tool. So let's go to next slide. Right, so this is what kind of a thing which we do have. A Y is binary, that is PT non-compliance in our case, that's what a case we are just taking simultaneously. Processing time non-compliance, causing non-compliance and not causing non-compliance. These are the two levels of Y. And X's, of course, these are the 8 X's: 1, 2, 3, 4, 5, 6, 7, 8. All these 8 X's are the critical X's which we segregated from CI matrix. And now out of these 8 X's, all we want to find out is how many X's are statistically significant. In other words, how many X's do have statistically significant impact upon PT non-compliance. And to figure it out, to find it out, we'll use statistical inferential test of chi-square test. We're also going to use graphical analysis based out of chi-square goodness of fit test. So let's go ahead and try and understand it. Let me read this statistical test again. To find out whether one or few of the X's out of these 8 critical X's, we want to find out whether one or few of out of these 8 critical X's do have statistical impact upon this project Y. And to do that, we use chi-square test for statistical testing, and for graphical analysis, we're going to use chi-square goodness of fit test. So how are we going to use it? Let's go to next slide to understand it. Next slide, please. Right, so before we proceed, as we all know, we have to have our hypothesis set. So what is our hypothesis over here? Our hypothesis is one or few of prioritized causes from CI matrix, that is segregated or prioritized causes from the CI matrix, have statistically significant impact on PT non-compliance. PT non-compliance is our processing time non-compliance. So this is a hypothesis, that is the first step. Second step, set HO, that is H0, and HA, that is alternate hypothesis. So set null hypothesis and alternate hypothesis. So what is my null hypothesis? Critical X's that segregated or prioritized from CI matrix have no impact on Y. Alternative hypothesis is one or few critical X's that segregated or prioritized from CI matrix have statistically significant impact on Y. This is where, and this is what the null hypothesis and alternate hypothesis we have said. So let's testify. So let's go to next slide. To deploy chi-square test, let's get back to data that we collected in major phase. If you could remember, we said that we are right now we are following pattern 1 or strategy 1, where we're supposed to collect data for one long month. So in major phase, we collected data for project Y as well as that for causes. If you could remember, we just mentioned 1001. Likewise, if there is an NC, we trying to figure out what probable causes are influencing, or if you could remember, we use the word culprit. What are those causes which lead given shape to be non-compliant? So we just mentioned one, or we denoted that cause with 1 and the rest of the causes with 0 for the given shift. And likewise, we kept on continuing doing it across all the shifts. We collected data for 30 long days, that is 1 month, which is nothing but 30 days into 3 shifts per day. That is close to 30 into 3 or close to 90 shifts we collected the data, if you could remember, in major phase for both project Y and possible critical causes. So let's go to next slide and try to somehow recall those things, or let's go to next slide and understand what data we have collected. This is what data we collected, if you could remember or if you could recall. So major phase and week and day, shift, and likewise, we added these numbers over here and total time in seconds for 10 individuals per shift, and then this divided by this will give us total processing time or average processing time. Now, once we receive average processing time, we compare it with client given specification limit. That is nothing but 270 seconds. So we try and compare it, this 250 with 270. Since this is less than 270, we are calling it compliance. And for compliance, we never did investigation. But if average processing time or total processing time per unit for a given shift is more than 270 seconds, we call it NC, non-compliance, and we got to investigate which are those causes which are culprit, causes which are culprit leading to this given shift to NC. So supervisors, assistant managers, and ground level team they will discuss about which of these 8 critical causes led to this NC, and then based on that they can either come up with 1 cause or 2 cause, or even for that matter all 8 causes. We never know, because these 8 causes, if you could remember, are segregated out of CI matrix. All it means is all these 8 causes are controllable, A, or highly controllable, B, they are highly severe, and C, they are highly frequent. All it means is there is a possibility if anything goes haywire or wrong with the given shift, chances are quite high that this abnormality is because of either of these causes or most of these causes. So all supervisor need to investigate is whether one of these causes or few of these causes or many of these causes, these 8 causes, are leading this particular abnormality. They're going to do it for every single shift. By the end of the day, they get this number, they'll put the details and they'll get these details, right? And we also said that they hardly consume 10 to 15 minutes per shift, right? Especially with the NC shift. For C shift, for compliance shift, they don't need to spare much time, right? So likewise, they collected the data for 90 long shifts, that is 30 days. So 30 into 3 goes to 90. Why 3? Because 3 shifts per day. Right? So this is what a data we had. Now what are we supposed to do with this data? So from major phase collected data, all we're going to do is we're going to put the filter over here, and we're going to take only data for NC non-compliances. So we are not going to take data for compliances. Let me repeat. From major phase collected data, we are not going to use compliances data. We're going to use this data for NCs over here. So you can just put a filter in a spreadsheet and just click on NCs, and you can get this NC data, right? So this is NC data. Of course, I'm going to show you all those things, so don't worry about that. We'll take a live case the way we took it for capability analysis, right? So this is the NC data. So we have this NC data here. This is the NC data for NC. Next slide. All we're going to do, or all we have to do, is we need to copy paste or copy this particular data and paste this amber color data into breadth affix or team breadth's statistical tool. And what statistical tool are we going to use? Let's go to next slide and check it out. So we're going to collect this amber color data, that is NC's data, this NC shifts all NC ships are there. We're going to collect this data, amber color data, and we're going to paste it here. This is our tool, team breaks tool. So we're going to paste it. So we copied it from there and we're going to paste it over here. Once we pasted it over here, we need to check number of causes, how many causes are there. So here, how many critical causes we had? We had 8. So we're going to mention 8 over here. So as we already mentioned that in a chi-square test, we can maximum choose 9 causes. But here, in this case, we only had 8 causes. So we'll remove this C9 cause. I mean, this title of C9. So important. You can read it over here. If there are 8 causes, remove title of C9 from the system. So we are going to remove this title. So there will be only 8 causes here. So we already pasted the data. We added the number of causes as 8. We have removed this title of C9 over here. That's what we did. So let's go to next slide. So let's recap what we did in the chi-square tool of the team break. So use measure phase data to execute chi-square test in chi-square tool shared with you all. By the way, by the end of this video, you can just download download this tool, which is given or shared with you in this video, right? So under measure phase data to use measure phase data to execute chi-square test in chi-square tool shared with you all. The very first thing, we're going to add number of causes 8, paste non-compliance data 8. I mean, for PT non-compliance we had 8. Perhaps for your project, if you're going to do any live project, there might be maximum 8 causes, 8 causes or 9 causes, or even 7 causes. Right. So whatever total number of critical causes you have to just mention it over there. But those causes shouldn't be more than 9 causes. You got to limit yourself to select up to 9 critical causes. Right. So once that is done, paste non-compliance data, which you already did it. Right. That amber color data you already pasted it. Then if there are 8 causes, remove title C9 from system as shown on a previous slide. So we already did that. And now all we need to do is we need to check p values A and B, graph of expected versus observed value. Now how it looks, let's go to next slide to understand it. But please do not forget to download the tool. This tool is ours, our family's tool, right? So you have the right to use that tool. That's not for a commercial purpose, definitely. That's for utilizing it for your own projects. So no companies can use it without the permission of team break, but you can use it because we all are family. Let's go to next slide. So this is how it will look. We already pasted data over here. We already put 8 over here, 8 number of causes. We removed C9 from here, right? Then all we need to do is we need to check p value over here. And we need to check this graph as well. So here, this black colored bar is for observed value, and this white colored or typically gray colored bar is for expected value, right? So what is p value over here? P value is 0.047, right? And you could see this graph with expected value, bar for expected value and bar for expected value. This gray colored bar is for expected value and this black colored bar is for observed value. So let's go and understand the inference. What inference we have over here? Since p value is 0.047, this is the p value, which is 0.047, which is lower than 0.05. It means there is 0.047 into 100 is equal to 4.7% of the risk to be absorbed. Why we want to absorb the risk? To accept the alternate hypothesis. And what was our alternate hypothesis? Alternate hypothesis was one or few of the critical causes from CI matrix do have statistically significant impact upon Y. So to accept this alternative hypothesis, we have to take the risk of 4.7%. Thus, we can infer that one or few causes from the list of prioritized excess influences PT non-compliance. So that's about the inference we have. Now, what is the conclusion? Conclusion is from graph of chi-square goodness of fit test, this graph I'm talking about. From graph of chi-square goodness of fit test, we can also see that observed value is higher than expected value for, you can see C5, that is cause number 5, cause number 7, and cause number 8. So observed value, that is black bar, is higher than gray bar. Hence, we can extend our conclusion that causes C5, C7, and C8 from the list of critically prioritized excess influence PT non-compliance statistically. In other words, C5, C7, and C8 are statistically significant excess. That's what we're going to find it, or we have found through this chi-square testing. So we started with the probable, with the list of probable causes. If you could recall, those were 21 in fishbone diagramming. Then through CI matrix, we reduced, or we trimmed that list from 21 to 8. And then with next level of prioritization, that is through statistical analysis, we have trimmed it down to 3 causes. So from 21 causes to 3 causes. So these 3 are the most significant causes which do have higher impact on a given Y. Imagine that had you needed to work on all 21 causes, how much money, how much efforts, how much time you needed to put to fix those causes. Now you got only 3 causes to work on, which do have relatively higher significance and higher importance. You can reduce your time consumption almost by 6/7 time, that is almost by 70 to 80%. You needed to reduce your money consumption almost by 70 to 80%, and of course efforts by 70 to 80%, if you're going to use statistical analysis. And that is the power of statistical analysis, and that is the power of Six Sigma or other problem solving methodologies, right? So that is why Six Sigma is one of the very, very powerful advanced analytical problem solving methodology or tools which you're going to get expertised into. So on that note, let's go to next slide. Let's go to summary of chi-square test and goodness of fit test. So after completing the statistical analysis, we got to put the summary table so that people can very easily see what are the different x's we testified with, what was a y, what was a p-value, and what are the inferences out of this statistical testing. So to start with, we had a y, processing time non-compliance, right? And these are the 8 different critical causes we had before we started with the test, right? These are the x's which we found through CI matrix, right? Chi-square test we deployed, and the p-value was 0.047. Post hoc statistical test, we use this test named post hoc statistical test, named the graphical analysis of chi-square goodness of fit test. And here we can find out whether observed frequency or observed value bar, that black colored bar, is relatively taller than bar for expected values. That's what we get to know from graphical analysis of this chi-square goodness of fit test. So just a moment. Right, so I have laser over here. Right, so graphical analysis of chi-square goodness of fit test. Right, so what have we observed through that graphical analysis? We observed that for C1, C2, C3, C4, and C6, let me repeat, for C1, C2, C3, C4, and C6, observed value is relatively smaller than expected values, or the bar of observed value is shorter than the bar of expected value. And that is why, C1, that is the first cause named product changes are made too often and without a plan. This particular cause has no statistically significant impact upon Y. That is what we observe. Similarly, for C2, C3, C4, and C6, observed value is smaller than expected value. That is the bar of observed value, the black colored bar in a graph is smaller than gray colored bar in a graph. So the color of the bar, color of the observed value bar is black, and color of the expected value bar is gray. Please do remember. So if observed value bar is relatively shorter, then that given X is not statistically significant. However, in case of C5, C7, and C8, we have observed that the bar, the black colored bar of observed value is higher or taller than the bar of expected value in that particular graph. And that is why C5, that is tool breakdown in machinery, is C5. It's significant X that need to investigate further and fix it with appropriate solution, suppose in improve X. C7, frequent waiting for approval. So C7 is statistically significant X that need to be investigated further and fix it with appropriate solution. Same with C8, that is high time for raw material inspection, is significant X, that is statistically significant X that need to investigate further and fix it with appropriate solution. So this is the summary of chi-square test, and of course goodness of fit test, the graphical analysis of goodness of fit test. So we started with 21 probable causes to 8 critical causes, and from 8 critical causes to 3, C5, C7, and C8 statistically significant causes. So that's about how we supposed to implement or deploy statistical test of chi-square testing, and of course how we can assess the graphical analysis of goodness of fit test, chi-square goodness of fit test. So that's about how we're going to implement the chi-square testing. So now let's take example. We had that data, measure phase data. Let's take the same data and do it live together. So let me go to Excel. So chi-square, right? So this is the data all we had, which we already have shown in a few of the slides. This is measure phase data which we collected for 30 days, right? So this is the data. So let me select this data or pick this data. I'm going to copy this data. So these are the data points. I'm going to copy it. So I'm going to copy this data, and I'll go to this sheet, a blank one. I'm going to paste it over here. So then I'm going to paste it. Right. So this will look like this. Now, all I need to do after pasting is this column, PT non-compliance column, right? I need to filter it out. So all I'm going to do is I'm going to click over here and I'm going to put filter, right? So this is the filter button. So I'll click on a filter, and here I got a filter, for all of these columns. So here in PT non-compliance, I'm going to click on the filter button, drop down button, sorry, and I'm going to remove the mark for compliance. So now I'm going to have the data only for non-compliance. As you could see, these are the non-compliance data, right? What next I need to do? I need to select the data for each causes from here to here, and I'm going to select it over here. You could see how I'm going to select it. I'm going to select it and I'm going to copy it over here. So copy, then I will go to our tool, right? This is the tool. I'm going to paste the data over here. So I have pasted the data over here. So here I'm going to put 8 causes, and since these were the blank over there, so we never had C9 here. So we are lucky. Had we have this C9 over here, we needed to remove it from there, from this particular title box. Now we pasted the data properly. This is the NCs. We pasted data. Once we pasted data, of course, we added the number of causes 8 over here. Then we are going to check the p-value. What is our p-value? P-value is 0.047. In other words, 0.047 into 100 comes to 4.7% of risk we got to take to reject null hypothesis. In other words, accept alternative hypothesis means to say that one or few of the critical causes from CI matrix are statistically significant causes, or they do have a statistically significant impact upon Y, right? So this has been proven that one or few of the critical causes from CI matrix do have statistically significant impact on a Y. But which are those causes? To find out which are those causes, we will go one step ahead, and with the help of chi-square goodness of fit test driven or based graphical assessment, which we can see over here, we can do that conclusion. So you can see that the bar of expected values are these black colored bars, and the bar of bar of observed values are this black colored bar, and bar of expected values are this gray colored bar. You could see for which causes the bar of observed values taller than the bar of expected values. If you really going to see it, it's very easy to find out. So this one, C5, C7, and C8. For these three causes, we could see the bar of observed value is taller than a bar of expected values. And that is why we can conclude that these three causes, cause number 5, cause number 7, and cause number 8 are statistically significant causes which do have statistically significant impact upon Y. So that's about the chi-square testing. How are we supposed to do it? So this is how we're going to do the chi-square testing. Shall we go ahead and do it again, so that I know this is a video, you can just rewind the video and then still can watch, but still let's go together and do it again, right? So let me go back. I'm going to go to this data, right? So I already have pasted it into a blank kind of a blank sheet, but before that, let me just remove it from here, right? So imagine I'm going to remove it from here. I have removed it. Then I'll go back to the data. I'm going to copy it over here only for NC data, right? Not for compliance data. I'm going to come back to the chi-square test. I'm going to test it over here. I'm going to put 8 over here, right? Had I have that C9, because this is C1, C2, C3, C8. Had I had C9, I will remove that C9 and make it blank, right? So it has to be blank. This particular column with that of the title need to be blank, right? So, or in other words, if the column is blank, the title is supposed to be blank. You need to remember that, right? So once that is done, all we need to do is we need to check the p-value, and after p-value, we need to check which causes do have a relatively taller black colored bar, or in other words, which causes do have higher observed value than the expected value. So all those causes do have statistically significant impact upon Y. So this is what we have in this statistical assessment. Let's get back to our presentation deck. Right, so here we were. Let's go to next slide. Right, so this is where this is what we have done with the analyze phase. Of course, with strategy number 1, right? Strategy number 1 talked about when we collected data for 1 long month, or when senior management allowed us to collect the data for 1 long month. Now, what if for any other project, when senior management is not allowing us to collect the data because of exigencies, or because of urgencies, and because of client want to solve a given problem as early as possible. In that case, when client is or when senior management is not allowing us to collect data, but for statistical assessment, we needed data, right? So all we did is like we ranked it. We had 10 different members and we ranked it, and we had that data, right? If you could recall. So all those things, how to deploy test with the help of that ranking, we're going to look into upcoming video, very next video. So meanwhile, let's go to the quiz, right? So question number 1, to find out whether one or few of segregated or prioritized causes from CI matrix, whether those do have statistically significant impact upon Y, we will use statistical test called chi-square or 2p test. And the answer is chi-square test. Now, what is 2p test? Maybe in next phase, the improve phase, we're going to look into what is 2p test. But right now, chi-square test. So to find out whether one or few of the segregated or prioritized causes from CI matrix have statistically significant impact upon Y, we will use statistical test called chi-square test. Next slide, please. In second question, in chi-square goodness of fit bar graph, bar of observed value should be taller than bar of expected value. True or false? And the answer is true. In chi-square goodness of fit bar graph, bar of observed value should be taller than bar of expected value. So let me read it. In a chi-square goodness of fit test bar graph, bar of observed value should be taller than bar of expected value. So this is the right answer. So it's supposed to be taller. The bar of observed value is supposed to be taller than the expected value. I keep on repeating these things because I want you to really remember these things. So that's how. Let's go to the next slide. So I guess that is what we have in how to deploy, chi-square test. I'm sure you found it very, very easy. Actually, we try to convert it to the easiest possible mode. We have worked on the different statistical tools, and you need to just click on different buttons, and it was quite confusing. So we decided to create a easy to use or easy to utilize kind of a chi-square test, and that's what we used it based on a spreadsheet. So I'm sure you will find it very easy when you're going to deploy this test or this tool for your statistical analysis, for your internship projects, at the same time for your real life projects too. So I guess on that note, let me again request you all, please help us to reach out to your friends, families, relatives, and neighbors, and let them know about our Breath of X program. Now we are family members, right? So I can definitely request you to do this. Please let them know, because together we can really build our nation. So that is what the ultimate goal of while deploying or while taking this initiative ahead of Breath of X. So on that note, Uttishta Bharata, Ma Bharati shall rise again in her full glory. So before we stop, before we end, let's go and thank technology companies for their for their technological support. So we deeply appreciate following technology companies for their technological support. Like the video, please like it. Please do share it with your friends, and if you have not subscribed, I'm sure you must have subscribed our Breath of X YouTube channel. But if you are not, please subscribe our YouTube's Breath of X channel. So on that note, thank you so very much for your time. Let's meet up in our next video, where we'll continue with statistical assessment for strategy number 2. Thank you so very much. Have a wonderful, wonderful time ahead.